Welcome friends for lecture number 4 on the chapter number 6 combustion in CI. In previous third lecture we discussed the combustion chambers considerations used in CI engine. Also we discussed the swirling motion, why the swirling motion is important in CI engine, and accordingly we discussed the different types of the swirling motion that is to be used in the CI engine. In that we discuss the induction swirl, how induction swirl is achieved, what are the advantages, what are the disadvantages. Next, that is the compression swirl. What is a compression swirl, how compression swirl is achieved, again the advantages and disadvantages. And lastly the combustion induced swirl, how it is to be achieved, what are the different advantages and disadvantages. Same time, the last we discuss the different statement about how to justify this statement. For example, the requirement of air motion and swirl in CI engine chamber is much more compared to the SI. We will also discuss on this statement why the swirling motion and air motion in CI engine is much more, why it is to be needed in case of CI engine compared to the SI engine, and accordingly we also justify the same statement. Also we discuss on the statement that justify the statement that why induction swirl in CI engine helps to increase the indicated thermal efficiency. Also we will discuss on this statement. Now today we will discuss the different types of the combustion chambers used in the correct. We will discuss the different types of the combustion chambers in the CI engines, and accordingly also here we discuss first the difference between the induction swirl and compression swirl that already were discussed in previous lecture. So first we'll discuss the induction swirl advantages. In induction swirl, first advantage is high excess air. High excess air, therefore indicated thermal efficiency is high. In compression swirl, less excess air, therefore lower indicated thermal efficiency. Means in induction swirl heat loss is less, in this case heat loss is more. Second advantage, due to low intensity of swirl, easier for starting. It is easier for starting. It is a cold starting trouble, cold starting problem is going to be achieved due to the high heat loss when the air is to be moved from main chamber to the additional or divided chamber. Then third advantage in induction swirl, no additional work for producing swirl. There is no any additional work is to be required to get the swirling motion, to get the induction swirl, and that's why high mechanical efficiency as well as the high brake thermal efficiency. Here work absorbed in producing compression swirl, means some energy is to be lost to produce the compression swirl. Because of that the mechanical efficiency is lower. In turn the brake thermal efficiency also lower. Advantage again, used with low speed, therefore low quality of fuel can be used. Here cylinder more expensive in construction, means design of this divided combustion chamber is expensive one. Construction is very, it is a very precise construction that is to be needed, and that's why the cost is more. Disadvantage, weak swirl, multi orifice nozzle required, high injection pressure required, correct closing of holes, high maintenance. Here single injector, pintle, pintox you can use, also less maintenance. Influences minimum quantity of fuel, complications at high loads and idling, large valves, higher volumetric efficiency. In induction swirl, shrouded valves, smaller valves, masking of valves lowers the volumetric efficiency. Here greater utilization of that air due to strong swirl. Meaning, then weak swirl, low air utilization, lower mean effective pressure, large size engine. Correct. Swirl proportional to speed, so suitable for variable speed operation. Swirl not proportional to the speed, efficiency not maintained in variable speed engine, smooth engine operation. Likewise, one can differentiate between the induction swirl and compression swirl. So this point is also maybe asked in the examination. Getting the differentiate between the induction swirl and now compression. Start the types of the combustion chambers. So as we know that the most important function of CI engine combustion chamber is to provide the better mixing of fuel and air in very short time, in very short period. So in order to achieve this, an organized air movement that is known as the swirl is provided to produce the high relative velocity between the fuel droplets and the air. Getting so to getting the better mixing of air and fuel in short time, we need some ordered air motion. This ordered air motion is known as the swirl motion, so that it will produce the relative velocity between the fuel droplets and air. So when the liquid fuel is to be injected into combustion chamber, the spray cone gets distributed due to air motion and turbulence inside the engine cylinder. So the onset of the combustion will cause an added turbulence that can be guided by the shape of the combustion chamber. So one also combustion once started, then also it going to add the ordered motion or disordered movement of this combustible products inside the combustion chamber. Getting so CI engine combustion chambers are classified into two categories. One, open injection type means direct injection type, and second, indirect injection type means IDI types. Getting so DI type and IDI type, open injection and indirect injection. So in open injection, this type of combustion chamber is also called, see, means DI type is also called as open combustion chamber. So in this type, the entire volume of combustion chamber is located in main cylinder. Getting so entire volume of combustion chamber is located in a main combustion chamber and fuel is injected in this volume, which is in the main engine cylinder. Whereas indirect injection type, that is IDI type, the combustion space is divided in two parts. Getting it is divided in two parts. One part that is a main cylinder and other part in the cylinder head. Getting one part in the main cylinder and other in a cylinder head. That's why the construction is a very precise, and that's why it is an expensive one. And the fuel injection is effected usually into the part of the chamber located in the cylinder head. It's partly the fuel is to be injected in this additional or divided that chamber which is located in the cylinder head. Getting so again this indirect injection type are again divided into different types, that is having again classified into the different types, namely swirl chamber, then pre-combustion chamber and air cell. So we will discuss about first open combustion chamber, that is a direct injection chambers. Getting direct injection chambers or open combustion chamber. So an open combustion chamber is defined as one in which the combustion space is essentially a single cavity with little restriction from one part of the chamber to other, and hence with no large difference in pressure between the parts of the chamber during the combustion process. So it is nothing but a cavity. It is nothing but a cavity means it is nothing but a space provided in the main combustion chamber. So such a cavity is provided in the piston. If you see at the piston crown, at the top of the piston, such cavities are to be provided of different shapes. Getting of different shapes, and that's why the fuel is to be injected over this entire volume, and that's why in open combustion chamber the whole combustion chamber is located, the volume of whole combustion chamber is located in the main, that is the engine cylinder. Getting so in four-stroke engines with open combustion chambers, induction swirl is obtained either by careful formation of the air intake passages, or by masking, or by shrouding, or by other ways, by giving the proper shape at the passages, at the inlet passages, we get the induction swirl in open combustion chambers. So these chambers mainly consist of space found between the flat cylinder head. So cylinder head is a flat. In open chamber, cylinder head is a flat, and cavity is provided in piston crown. So various types of shapes are provided in the piston crown, top of the piston. Likewise here, the less cavity is provided. Here, the more cavity is provided. Depth is more. Here, depth is a less. Meaning, and the fuel is injected directly into this space. And the injection nozzles used for these chambers are generally multifold type, working at relatively higher pressures, around 200. So for open combustion chambers we require the multifold fuel injectors or fuel nozzles. Meaning, so main advantage of these chambers are minimum heat loss. Getting minimum heat loss. Heat loss is a minimum because lower surface area to volume ratio, hence better efficiency. Surface to volume ratio is a lower, that's why efficiency is more and the heat loss is also less. No cold starting problems, as heat loss is a less, means there is no any problem arises due to the cold starting. Then fine atomization because of multi-hole nozzles, as injector use that is a multi-hole, and which are going to inject the fuel at very high pressure, relatively high pressure, around 200 bar. That's why in this case what happens, the atomization is a very good, fine atomization is a possible. Drawbacks: high fuel injection pressure that is to be needed, hence complex design of fuel injection pump, as in this case we require the high injection pressure around 200 bar. That's why the whatever the design used for the fuel injection pump is a complex. Then necessity of accurate metering of fuel by injection system for small engines. So again the fuel injection system is plays important role in open combustion chambers. So now these open combustion chambers are divided in different types, namely shallow depth, hemispherical, cylindrical, and toroidal chambers. So first we will discuss the shallow depth chamber. Now how we are going to differentiate? Again with the cavity provided in the piston crown. Getting the shape of that piston, shape of this cavity provided in the piston crown. Accordingly, there are different types are there. So first shallow depth chamber. So in shallow depth chamber, the depth of the cavity provided in piston is quite small. If you see here, the depth provided in a piston crown is a small depth. Getting cavity that is a small one, and this chamber is usually adapted for large engines. Generally, this is used for the large engines running at low speed. Obviously, large engines running at low speed. Since the cavity diameter is large, the diameter is a large, so squish available is a negligible. The squish, that is a motion available inside the combustion chamber, that is a less. That is air motion, that is known as a squish, that is a less. Getting due to this volume to surface to volume ratio. Again, the depth to diameter of cylindrical chamber can be varied to give any desired squish to give the better performance. If we are going to give the more depth according to the diameter, what happens? We are getting the different that squish. We are getting a different air motions in this shallow depth chamber for better performance. Then hemispherical. So the chamber to give better performance. So in hemispherical, if you see here, again in hemispherical, the depth of cavity is a more. Cavity depth is a more cavity depth is to be provided. So this chamber also give the better or small squish, and again the diameter diameter to depth ratio. That is plays important role. Getting. However, so depth diameter ratio of this cylindrical chamber can be varied. You can vary to get the desired squish. Get it? To get the desired squish. So again, hemispherical shape is provided in the cavity. That's why it is known as the hemispherical cylindrical chamber. So this design is attempted in recent diesel engines. Again, the cavity of shape is a cylindrical one in the cavity. And this modification of cylindrical chamber in the form of truncated cone. So it is a truncated cone. What a truncated cone with the base angle 30 degrees. You correct these two sides of this truncated cone. The angle is a 30 degree. So the swirl was produced by masking. So whenever the air is to be induced in the chamber through the intake passages, through the intake wall, by that way the masking is provided for the wall, and by that way we get the swirling motion. Meaning, so squish can be also varied by varying the depth. The depth is to be varied. Again, the squish motion or air motion is to be varied. Then next, toroidal chamber. That is a toroidal chamber. So the idea behind this shape is to provide a powerful squish. You see, such a toroidal shape is provided. Because of that, what happens? Whatever the airflow mixture that is to be in these passages, in this cavity, it gets compressed and ejected instantaneously. When the piston reaches to the compression, it reaches to the TDC in a compression stroke, and this ejected air fuel mixture is produce the squish motion or air motion, provide the swirl motion to the inside the combustion chamber. So it provides a powerful squish. Getting. So again, the one can also increase again this swirling motion by proper masking at the inlet passages or inlet wall. So again, the spray cone angle is 150 degree to 160 degree. Multi-hole, again the multi-hole injectors have to be used. So in all open combustion chambers, we are going to use the multi-hole fuel injectors because we need the high injection pressures. It is possible with only the multi-fuel injectors. So these are the four types of the cylindrical chambers used in the open combustion. Now we'll discuss the indirect induction chambers. So what is the indirect chambers? A divided combustion chamber is defined as, indirect means divided combustion chamber is defined as one in which the combustion space is divided in two or more distinct compartments. Getting? It is to be in two or more compartments. As in open combustion chamber, main combustion chamber means entire that combustion chamber is located in the engine cylinder itself. But in indirect or divided combustion chamber, the combustion space is divided in compartments, two or more compartments. And this creates the considerable pressure difference between them, between these divided combustion chambers, during the combustion process. So accordingly, there are three types we have to discuss. First, we will discuss the Ricardo swirl chamber. First, we will discuss the Ricardo swirl chamber. So here it is figure is to be shown. So this spherical shaped swirl chamber. So this additional chamber is provided in the cylinder head. Getting, and this additional chamber is connected with the main chamber. Here main chamber is there. It is connected with the main chamber through these restricted passages known as a throat. So swirl chamber consists of a spherical shaped chamber separated from engine cylinder. So it is separated. This swirl chamber is separated from the engine cylinder and located in the cylinder head. So into this chamber, about 50% of air is transferred during the compression stroke. 50% of air which is in the main engine cylinder is forced into this chamber. It is compressed, it is transferred from main combustion space or main combustion chamber to this additional chamber. through this throat. So throat connects the chamber to the cylinder, which enters the chamber in tangential direction, so that the air coming into this chamber is given a strong rotary movement inside the swirl. So this restricted passage is provided, this throat. So when the air, compress the air from main chamber is to be enter into this swirl chamber, getting in a tangential direction. So air coming into this chamber is having the rotary motion, strong rotary movement inside the swirl chamber. Getting in this way it was the swirling motion, that is known as the compression swirl. Getting compression swirl. And after the combustion, the products means when combustion begins in this additional chamber or in this swirl chamber, the products rush back into the engine's main engine cylinder through the same throat at much higher velocity. Getting because the restricted passage is there. As passage is restricted, so once combustion is started in this swirl chamber, so whatever the products are combustion, they are again rushed back into the main chamber, getting through this throat at much higher velocity. So this causes the considerable heat loss. So during this, what happens? First, when highly compressed air is moving from main chamber to the swirl chamber, heat loss is there. So proper insulation is to be provided. Same time, when the combustible products that they are going to be rushed back from swirl chamber to the main chamber, there is a heat loss in the passage between the additional chamber and this main chamber. So this type of combustion chamber finds the application where fuel quality is difficult to control, where reliability under the adverse condition is important. Then the fuel economy. Meaning means any type of fuel, cheap quality of fuel you can use for this swirl chamber. So it uses the hole single hole fuel nozzle or single hole injector is to be used in this case. So this is about the Ricardo's swirl chamber. Next part we'll discuss in the next thing.